Okay, we're going to cover numerical integration. I'm going to start off with the trapezoidal rule. The trapezoidal rule says if you want to find the area under the curve of f of x from a to b, this is always approximately b minus a divided by 2n times f of x0, and x0 is always a, plus 2 times all the others, f of x1 plus 2 times f of x2, all the way down to the next to the last one, f of xn minus 1. This gets times 2. But the last one, f of xn, and xn is b, that just gets multiplied by 1. There's no 2 in front. So other than the first one and the last one, they all get multiplied by 2. That is f for something, f for something, f for something. They all get multiplied by 2, except the first and the last one. Now how do you get the x0s and the x1? Well, x1, you just add delta x. That gives you x1. To get x2, you take the one before and you add delta x. To get x3, you take the x2, the one before, and you add delta x. That's how you get the next one. You add delta x. And delta x, like always, is b minus a over 2n. So let's try to do an example. Suppose you want to find the area under the curve from 3 to 5 of x squared dx. And I tell you n is going to be 4. Okay. So the problem says approximate that area using 4 rectangles using the trapezoidal rule. Okay. First thing you do is you have to find delta x. It's b minus a over n. There's b, there's a. It's 2 over n, and it's given to be 4, so delta x is a half. X of 0 is always a, it's always the lower limit. You add a half to it, you get the next one. 3½ is the same as 7½ You add delta x, that is, you add a half to the one before, you get 4. You take 4, you add 1 to it, you'll get x3. 4 plus a half is 4½ or 9½ You add a half to 4½ and you get 5, which is where you stop. x0 is a, in this case x4 is b. We stopped at 5. Okay, and then we apply the trapezoid rule. The integral, well, it's right in front of me. So that integral is approximately equal to b minus a, which is b minus a in our case is 5 minus 3 or 2, divided, so you have 2 divided by, I won't even compute 2 times 4. The reason is the 2's cancel, so I get a quarter. It's just 1/4. Okay, so it's 1/4 times f of x0, that is f of 3, plus 2 times f of 3½ or 7½ f of that, excuse me, plus 2 times f of 4, plus 2 times f of 4½ plus, since it's the last one, is just 1 times f of 5. and f just squares. That is, we have a quarter times f for 3 is 9, plus 2 times f for 7 halves is 49 quarters, plus 2 times f for 4. F for 4 is 16. F is just the squaring. By the way, that's f. I should have stated that. Plus 2 times f of 9 halves. But f of 9 halves is 81 quarters. Plus f for 5 is 25. And then you do some math. You have a quarter times 9 plus 32. 9 plus 32 plus 25. And then we have some halves. 2 goes into 4 2 times. So you have 49 halves plus 2 goes into 4 2 times. You have 81 halves. So you have a quarter times, well, 49 over 2 plus 81 over 2, that's 130 over 2. That's 65. Plus 25 plus 32 plus 9, that looks to me like 60, 80, 110, 120, 131. Try it again, make sure I'm right. 5, 7, 131. So the answer is 131 over 4. That's what we approximated the area to be using the trapezoidal rule. Let's try this all over again with a different function. Suppose you want the integral from 6 to 7, and you want to integrate x plus 1 dx. And I tell you, n is 4. N is 4. The first thing you do, and this is how you study. You have to say, when I'm giving a trapezoid, I'll use a trapezoid rule. When I'm given a trapezoidal problem, the first thing I'm going to do is find delta x. You need to be able to recite the steps, so then you know what the order of the steps are. The first thing is you find delta x, which is b minus a over n. That's a, and that's b. B minus a over n. And this is 1/4. So I need to find the x0s and the x1s, and if we need b, the x2s, etc. x0 is a. In our case, it's 6. And you add 1/4. The x1 is 6 1/4. And x2 is add 1/4, is 6 1/2. And x3 is you add 1/4. So now you have 6 3/4. And x4 you add 1/4, you get 7, and that's where you stop because that's b. So you stop when you hit b. You start off with a, and you add 1/4, and you add another 1/4, and you add delta x, another 1/4, and you keep doing this until you get to b. Okay, the next thing you do is you say that this integral is approximately equal to using the trapezoid rule with 4 partitions. You have what? You have b minus a, which is 1 over 2n. N was 4, so now you have 8. And then you have f of 6 plus 2 times f of 6 1/4 plus 2 times f of 6 1/2 plus 2 times f of 6 3/4 plus just f for 7 because that's the last one. The first and the last one, they're not being multiplied by 2, but all the other ones are. Every other one is. Okay, now what's f of a number? You add 1 to it. Just add 1. That's the rule. So you have an 8th, f of 6 is 7, plus 2 times f of 6 1/4. Well, that's 7 1/4. Plus 2 times f for 6 1/2. Well, that's 2 times 7 1/2. Plus 2 times f for 6 3/4, which is 2 times 7 3/4. Plus f for 7 is 8. Alright. This is 1/8 times 7 is 7 plus 2 times 7 is 14. 2 times 1/4 is 1/2. So you have 14 1/2 plus 2 times 7 is 14 plus 2 times 1/2 is 1. 2 times 7 1/2 is 15 plus 2 times 7 is 14. 2 times 3/4 is 1 1/2. So it's 14 plus 1 1/2, or 15 1/2 plus 8. Well, let's see. Here's 1/8. 7 plus 8 is 15, plus another 15, that's 30. 14 1/2 and 15 1/2. Well, the average is 15. Adding 14 1/2 and 15 1/2 is the same as adding 15 and 15, which is 30. Or 14 plus 15 is 29, plus 1/2 is another 1. 29 plus 1 is 30. In either case, we get 60. And 4 goes in here 15 times, and 4 goes in here 2 times. So you get 15 halves, or 7 1/2. The area under the curve of the the area under the curve x plus 1 from 6 to 7 is about 7 1/2. For example, here is the line y equal x plus 1. We want the area between 6 and 7. We claim that it's approximately 7 1/2. We can find the exact area. I mean, it's just a trapezoid. We can find the exact area. We can see how well or how poorly the trapezoidal rule works. Once again, here is our graph. We want to go from 6 to 7. Okay, now I know that the y values are 1 more than the x values. It's 7 and 8. That is, this distance is 7, and this distance is 8, and from 6 to 7 is 1. Now, I can rotate the trapezoid. It will then look something like this. It would look like this, where, let's see, I rotated it 90 degrees. So this is 7. This we don't know. This is 8. Okay, and this is 1. So we know the two bases. So the formula for the trapezoid rule is to find the average of the two bases and multiply it by the height, which is 1. Oh, that's 15 halves times 1. Our answer was exact. Our approximation was in fact no approximation at all. It's 15 over 2. It's exactly the right answer. Okay, so sometimes the trapezoid rule will give you an exact answer. I take it because our example was linear to the, I take it because our example, our function was linear. It was to the first degree. Okay, so there are a couple of examples using the trapezoidal rule. Just remember to multiply those x sub i's by 2, except for the first and the last one. Always by 2, except for the first and the last one. Okay, that finishes the trapezoidal section.